USCRPL starts their Kiwi engine testing, DH Rocketry experiments with some toxic fuel, ARIS tests out some new landing technology. This is your amateur rocketry news for the month of December. As we've mentioned on this channel before, USCRPL is a student rocketry group from the University of Southern California. They're focused on building rockets, and they currently have the record for the highest flying rockets ever developed by a student group. However, they want to break that record again and also break the overall record for the highest rocket ever flown by an amateur group. This is the goal of their vehicle, the Dome Piercer. In order to develop this vehicle, they need to enhance the formula that they used for their solid grain from their past vehicle which broke the record, the Traveler 4. This is where the Kiwi test stand comes in. Its job is to test the pressure, temperature, and the regression rate of the fuel as it burns. These are all important parameters which will determine how powerful the rocket engine will be and also how much material you need to contain the reaction inside of the combustion chamber. During its testing campaign through the month of December, the Kiwi engine test stand was subjected to over 20 tests of its fuel grain. There's really only one way to test a solid rocket. You just have to light it.
Just do it!
One of the most important parameters for a solid rocket is its regression rate. This is how fast the propellant inside of the combustion chamber is burning up or regressing. The rate at which this is occurring will determine how much exhaust gases are coming outside of the combustion chamber and how much pressure that combustion chamber is under. As rocket engineers, we want to make sure that the pressures are within tolerances for the combustion chamber that we've designed. Otherwise, we might get an explosion. The Kiwi engine testing campaign ended quite successfully. The UCRPL team now has lots of data to use in order to design their next engine. Next up, we have a group that's been experimenting with some toxic propellants. DH Rocketry has developed their Genesis rocket, which is actually using hypergolic fuels. What this means is that we have a chemical combination in which as soon as the chemicals are in contact with each other, they will react. This is actually a somewhat simpler rocket engine design because we don't need an igniter to initiate the reaction, we just have to mix the chemicals. However, this simplicity does come at a cost. You might imagine that having materials that react so vigorously might be a bit of a safety concern. There needs to be lots and lots of care taken to make sure that when hypergolic chemicals are being utilized, that they are only mixing when we want them to, on the launch pad. With that in mind, DH Rocketry has designed and constructed their Genesis rocket. This is powered by a combination of white fuming nitric acid and furfuryl alcohol. As I mentioned before, these chemicals are hypergolic. With this fuel combination, they're able to achieve a maximum thrust of 8.9 kilonewtons. Furthermore, after a successful launch, the Genesis rocket was able to get up to 3,000 meters in altitude. Unfortunately, the recovery system was not so successful and had some issues with its parachute on the way back down. In the end, it ended up as a bit of a crumpled mess on the ground. Nonetheless, the Genesis rocket mission certainly represents a step forward for amateur rocketry in terms of developing hypergolic fuels. Finally, there was some interesting news in the European amateur rocketry community. A student university group called ARIS started testing some new landing technologies that they want to use in some future missions. Parachutes have been the standard for amateur rocketry recovery for many years, but ARIS wants to change this up a little bit. As the altitude targets of amateur rockets gets higher and higher, what is also happening is that the downrange distance that these rockets are traveling is also getting further and further. The issue with this is that the further you are downrange, the less confidence that you have that you're actually going to land in the area that's been designated for you. The way that ARIS plans to combat this issue is to actually add guidance to their recovery system. Parachutes don't have any guidance, and they kind of just go wherever the wind takes them. But ARIS wants to add an airfoil into their recovery system so that they'll have the opportunity to fly the payload into the exact landing spot that they have designated for the vehicle.
That wasn't flying, that was falling with style.
This could actually be a really big step forward for amateur rocketry. Over the past month, ARIS was able to conduct a series of drop tests from a helicopter in the Alps in order to verify this airfoil design. That's certainly the scenic way to conduct these tests. And wow, look at those views. The airfoil recovery plan that Aris is planning for their rockets is actually quite similar to the recovery strategy that Rocket Lab wants to use for their commercial rocket. It's also using an airfoil which a helicopter will come and catch. So there's certainly some commercial value to developing a landing system such as this. We look forward to the future progress that the Aris team will have. To keep up to date with the progress of the amateur rocketry community, be sure to subscribe. We post monthly updates on what's going on in the amateur rocketry community. And be sure to check out the next video. We'll be covering all the highlights from the year of 2021, and maybe also discuss some of the records that were broken. And remember to expand your horizons.